Hi guys, okay, what I want to show you is just a couple of examples about how we use vectors with forces. I mean, to be honest, those of you who are sharp will realise we've already actually been using a vector idea all the way through this, but we just haven't been writing them as vectors. We've been talking about the lefts and the rights and the ups and the downs. So let's actually take a question where it might be easier to think about it with vectors. Now this is a system in non-equilibrium, it's not in equilibrium. So this isn't going to be like the questions I'm about to set you today, but it might help you with question 1 on the homework. Let's say we have a force up here of 10 newtons at an angle of 30 degrees. Then we have a force over here at an angle of 60 degrees. And that can be 18 newtons, and a force down here of 30 newtons straight down. So there's your y, if you like, and there's your x. And all I'm going to ask you to do is find the resultant, find the magnitude, of the resultant force. Okay, that's what we're actually going to do. And while we're at it, actually find the angle alpha it makes with the vector I. Okay, right, this isn't as bad as it looks, particularly if you use vectors, if you ask me. Right, each of these forces, let's call this one P, this one Q, and this one not R, but S. Now, the vector P plus the vector Q plus the vector S will equal our resultant force. So if we write P as a vector, well, clearly we've got that and that contributing, the X component and the Y component contributing to the force P. The X component will be 10 cos 30, and the Y component will be 10 sine 30. And that's P done, that's P. Q will be simply 0 in the X direction and minus 30 in the Y. Notice it's minus because it's going down. S will also have some negatives in it, because this will be 18 cos 60, but it will be negative 18 cos 60, and then that will be 18 sine 60, positive because it's going up, and that will equal our R. So that's P, that's Q, and that's S. So R simply equals, now I'm just going to stick all that into my calculator, and I'm just going to quickly get it from my bag. R is simply going to be 10 cos 30 minus 18 cos 60, and that's going to give you a final value of minus 0.33, well, minus 0.34 for X. Check you get the same number on your calculators. For Y, I'm getting 10 sine 30, and then I'm getting minus 30, and then plus 18 sine 60, and I'm getting minus 9.41 here. Now it's just occurred to me that I didn't leave my first answer to 3 significant figures. Oh no, I did, because it's minus 0.340, so that's all good. Both given to 3 significant figures. Now I haven't actually found the value of R yet, because how do we find the magnitude of a vector? Well, Pythagoras. We need that, and that's worked out by doing 0.34 squared, forget the negative, who cares about the negative because we're squaring it, 9.41 squared square rooted, and I make that 9.526. That is the magnitude. 5256, sorry, 9.53. Poor rounding from Mr. Nichols there, apologies. As for alpha, well, for alpha we're just going to have, think of this vector, it's really 0.3 across and minus 9.4 down. So it's like that. That's what that vector actually looks like. That's the resultant vector. It's going to go in that direction. Negative 0.34 and minus 9.4. That angle is going to be the angle it makes. Oh, sorry, no. There's the vector I. So strictly it's going to be that angle there. So if we find this angle and do 180 minus, then we can find the angle the vector makes with the vector I. So if I just say tan alpha, or let's say tan beta, if I call that beta, that thing in there where I've just made a mess, sorry about that. Tan beta is opposite 9.4, we'll forget the negatives because they're just lengths, over adjacent, which is 0.34. 9.41, sorry, isn't it? Yeah. So beta is inverse tan of that. And that gives me 87.9 degrees. And so alpha is 180 minus that. And 180 minus that answer is 92.1 degrees. And that one's done. Right, just before, what I'd like you to do today is finish all of exercise 4b. Okay? You might find question 4 confuses you, but just remember, for question 4, if you've got 3 forces, I think it's 3 minus 4 plus minus 5, 8 plus AB. If these 3 forces are in equilibrium, then they equal 0. The resultant force is 0. So then you can very easily see that A must be 2 and B must be minus 4. That's how easy that question is. Okay, have a go at exercise 4b. Good luck.